Hello, welcome to another lecture. In this lecture we will see digital filters. So digital filters are digital techniques for the processing of analog signals. First, an analog signal is converted into digital signal using analog to digital converter, and this digital signal is processed in a digital signal processor, and finally this processed digital signal is converted back to analog signal by using digital to analog converter. Basically, there are two types of digital filters, FIR and IIR, finite impulse response filter and infinite impulse response filter. So let us see this FIR and IIR filters and difference between these two filters. So in FIR type of filters, the impulse response is of finite duration, that is why its name is finite impulse response filter. And in IIR, infinite impulse response type of filters, the impulse response is of infinite duration and hence the name IIR. In FIR type of systems, present output depends only upon present and past inputs, so there is no feedback path from output to input, hence these systems are also known as recursive systems. In infinite impulse response type of systems, present output also depends upon past output, so there is a feedback path from output to input, hence these systems are also known as recursive systems. Next is that stability of FIR system can be guaranteed because all the poles exist only at z equal to 0, that is inside the unit circle. While in infinite impulse response system, stability cannot be guaranteed because poles can be present both inside as well as outside the unit circle. FIR type of systems can be designed as linear phase system without affecting the stability of system, while in infinite impulse response type of systems, linear phase can be obtained but at the cost of stability, hence these systems cannot be designed as linear phase system. So in finite impulse response system, to obtain the same frequency response as in case of IIR system, the number of points in these systems must be increased, which results in slow speed of the response and high complexity of the system because more memory elements will be required to store increased points. In IIR type of systems, speed of response is very fast and these are less complex systems, hence these systems are preferred where real-time signal processing is absolutely essential. FIR systems are preferred where distortion cannot be tolerated, such as image processing and speech processing. IIR systems are preferred where speed of response is absolutely essential, such as military operations. So these were important points regarding FIR and IIR filters. Now we will move to linear phase systems. Linear phase systems. When the phase of a system is linear function of frequency, such systems are known as linear phase system. For a linear phase system, the output is always exact replica of input except for constant amount of delay. So for a system with frequency response h e to the power j omega, output will be same as input but delayed in time. So let us see, in linear phase system, let us say input is xn. This is our system, LTI system, and yn is output. If it is linear phase, then yn will be yn minus n naught. Let us say n naught is some time by which input is delayed at the output. So we know its output will be x of n minus n naught. Yn will be x of n minus n naught. Xn delayed by n naught means x of n minus n naught. So we know if xn has Z transform or DTFT as x e to the power j omega, then this yn is x of n minus n naught. It will have DTFT x e to the power j omega e to the power minus j omega n naught. This is y e to the power j omega. So we know that this yn for any LTI system can be written as xn convolved with hn, where hn is impulse response of this LTI system. Then y e to the power j omega will be x e to the power j omega multiply with h e to the power j omega. This is convolution in time domain property of DTFT. So here we can see that y e to the power j omega is e to the power minus j omega n naught x e to the power j omega. By comparing this equation from previous equation, we can see that this is DTFT of impulse response of this LTI system, which is linear phase. So for linear phase system, its impulse response will have DTFT as e to the power minus j omega n naught. So we can see here that its phase h e to the power j omega we can write as amplitude 1 and phase as minus omega n naught. So there are two important terms which are phase delay and group delay. Phase delay and P can be defined as the delay provided at a single frequency is known as phase delay and is given by minus theta omega by omega. Delay provided at a single frequency is known as phase delay and is given by Np minus theta omega by omega, where this theta omega is phase which is a function of frequency. As we can see here, theta omega is minus omega n naught. It means minus omega n naught can be plotted as the line something like this. This is minus omega n naught. So we can see that phase, this is phase of h e to the power j omega. So phase is a linear function of frequency. It means it is linear phase system. Now we will see group delay, which is denoted by small ng. So the delay provided at a group of frequency is known as group delay. And this group delay ng is given by minus d theta omega by d omega, means derivative of phase with frequency. So for a linear phase system, the phase delay and group delay are not only constant but they are equal. These are not only constant but are also equal. Means in previous system here we can see phase is minus omega n naught, which is function of frequency theta omega, is minus omega n naught. Its np phase delay will be minus theta omega by omega minus omega n naught by omega, means n naught, and its group delay ng will be minus d theta omega by d omega, means minus d by d omega of minus omega n naught, which is n naught. Here phase delay and group delay are not only constant but are also equal. It means the given system is linear phase system. So this is one method to find the given system, and if the system is having Hn with frequency response He to the power j omega, then phase of He to the power j omega, which is theta omega, it should be constant function of frequency. Then it will be linear phase system. So let us stop this module here. Thank you.